Hi everyone, and welcome to this video. Today, we're diving into a crucial topic for anyone working with Solidity, understanding when and why to choose uint8 instead of the more common uint type. Making the right choice here can significantly impact your smart contract's efficiency and readability. First, let's understand the basics. In Solidity, uint is an alias for uint256. This means it's designed to store very large non-negative integers, up to 2 to the power of 256, 1. It occupies a full 32 bytes, 256 bits, in storage. On the other hand, uint8 is a specific, smaller unsigned integer type. It can only store non-negative numbers from 0 up to 255. It takes up just 1 byte of storage. So, why would you ever choose uint8 when uint seems to handle everything? The primary reason is gas efficiency. The Ethereum Virtual Machine, EVM, operates on 256-bit words. While uint naturally fits this, using smaller types like uint8 can lead to gas savings through a concept called storage packing. When you declare multiple small variables, like uint8, uint16, uint32 consecutively within a struct or a state variables, Solidity tries to pack them together into a single 256-bit storage slot. If you have, say, 32 uint8 variables, they could all fit into one slot, saving you the gas cost of 31 additional storage slots compared to using 32 separate uint256 variables. This packing mechanism is a huge gas saver. Another benefit of uint8 is clarity and readability. When a variable is declared as uint8, it immediately signals to anyone reading your code that this value is expected to be small, never exceeding 255. This helps prevent logical errors and makes the code's intent clearer. It also acts as a built-in constraint. If a value accidentally tries to exceed 255, it will revert in Solidity 0.8.0 plus due to default overflow checks, indicating a problem. Now, let's talk about when to use uint8. You should consider uint8 for variables that are naturally constrained to a small range. For instance, if you have a status code that can only be between 0 and 5, uint8 is perfect. Similarly, for item counts in a limited inventory system where the count will never exceed 255, uint8 is ideal. It's also great for short IDs or enum values that represent a small set of options. If you're managing flags or permissions where each bit of a byte could represent a different setting, uint8 becomes very useful. Crucially, when designing structs with multiple small state variables, declaring them consecutively with uint8 or other small uint types is a prime opportunity to leverage storage packing and significantly reduce deployment and transaction costs. However, there are times when you should definitely not use uint8. The most obvious is when your number might, at any point, exceed 255. If there's even a slight chance a counter could go to 256 or higher, you must use a larger uint type, like uint16, uint32 or uint256. Forcing a value into uint8 when it might overflow will lead to critical errors or unexpected behavior. Also, while uint8 saves storage gas, the EVM still processes data in 256-bit chunks. Sometimes, if you're performing many arithmetic operations on uint8 variables that are not efficiently packed or are frequently converted to uint256 for computation, the gas savings might be negligible or even slightly more expensive due to conversion overheads. This is less common but worth noting for advanced optimization. Always prioritize correctness and clarity over micro-optimizations if the range is uncertain. In summary, uint8 is a powerful tool for optimizing gas costs in Solidity, especially through storage packing, and for enhancing code readability. Use it wisely for small, constrained values, and always be mindful of potential overflows. Thank you for watching this explanation. I hope it helps you write more efficient and robust smart contracts. If you found this video helpful, please give it a like, leave a comment with your thoughts, and don't forget to subscribe for more content like